How can you figure out how much money you need to save for retirement? To start with, let's take a look at this question using a simple example. Later in the course, we'll add some complexity. Let's say you save 20% of your after-tax income every year. You work for 45 years and then retire. To keep the problem simple, we'll assume that you will live 25 years in retirement and then die. Why does this make things simpler? Because you know exactly how many years you need to support yourself in retirement. When you retire, you want your standard of living to stay constant. So you'll need an income that grows with inflation. You want periodic payments growing with inflation for 25 years. Periodic payments growing at a constant rate for a fixed number of periods is a growing annuity. While in reality, you'll probably want to receive your income monthly, we're going to assume that you get your payments at the end of every year. You'll buy the annuity with money that you saved while you were working, and this annuity will make payments to you in your retirement. We're going to assume that your retirement savings compounds at a constant interest rate. We're also going to assume that your income grows at a constant rate. That is, you get annual raises. And since you're saving 20% of your after-tax income, the amount you deposit in your retirement savings account is growing every year. So you are making periodic payments into your retirement account for a specific number of periods, and your payments are growing at a constant rate, and the interest rate is constant. Your savings, your retirement savings, and the payments that you're making to your retirement are a growing annuity. So first we need to figure out how much money you're going to have when you retire. That is, we need to calculate the future value of a growing annuity. Here's the formula for the future value of a growing annuity. Future value equals C, that's the amount of the first payment, times 1 plus r to the t power minus 1 plus g to the t power divided by r minus g. The amount of the first payment is C. The number of periods is T. In this case, 45 years, because you are working 45 years and making 45 payments into your retirement account. The growth rate is G. In this case, the rate of your annual raises, and the interest rate that you earn on your savings is R. You're going to take your total retirement savings when you retire in 45 years and then buy a growing annuity. We'll want to calculate how much money you receive from the growing annuity in the first year, that is year 46. The formula for the present value of a growing annuity is PV equals C divided by R minus G times the quantity 1 minus 1 over G divided by 1 plus R, all raised to the T power. In this case, PV will be the value of the annuity when you buy it. That will be your retirement savings. You're going to take your retirement savings and buy an annuity. R is the interest rate. G will be the inflation rate. Why? Because you want your income in retirement to grow with the cost of living. So we're going to have your income, what your annuity pays out, growing at the inflation rate. I'm assuming that you receive your annual payments at the end of each year, implying that you pay all your bills at the end of the year. Doing so makes the calculation a bit simpler. A more exact calculation would have monthly payments and shift the first annuity payment up 1 month. Now, we need to fill in some numbers. Let's assume that your annual salary the first year you work is $40,000. Your federal and state income tax, Social Security taxes, and Medicare taxes total 25% of your income. So your after-tax income is $40,000 times 1 minus 0.25, which equals $30,000 your first year. You're saving 20% of your after-tax income, so the first year you save 2.20 times $30,000, which is $6,000. Let's assume that the annual inflation rate is 3% and that you get an annual raise of 4% and the annual interest rate is 6%. How much is your retirement savings worth when you retire? we solve for the future value of a growing annuity. The future value of your retirement savings equals your first annual savings of $6,000 times 1 plus the interest rate of 6% raised to the 45th power, because you'll be saving for 45 years, minus 1 plus the growth rate of 4% raised to the 45th power, and that's because your salary is growing 4% a year, and thus the amount you save every year is growing 4%. And all of that divided by 6% minus 4%. That works out to $2,377,031. Looking pretty good. How much income will that get you in retirement? To calculate this, we need the formula for the present value of a growing annuity. We need to calculate the present value of the annuity you buy at the time you buy it. That is when you retire. Actually, we know that amount. That's going to be $2,377,031. What we're after is the size of the payments you'll receive. The formula is PV equals C over R minus G times the quantity 1 minus the ratio of 1 plus G divided by 1 plus R, all raised to the T power. PV, when you buy the annuity, is $2,377,031. The growth rate will be the rate of inflation, 3%. The interest rate is 6%, and you'll receive payments for 25 years. Plugging in numbers, we get $2,377,031 equals C divided by 6% minus 3% times 1 minus 1.3 divided by 1.6, all raised to the 25th power. Solving for C, we get $139,238. That's your income in your first year of retirement. How does that compare to what you earned the last year you work? Well, the first year you work, your income is $40,000. And for 44 years, you get a 4% raise. So in your 45th year, at the end of which you retire, your income is going to be $40,000 times 1.04 raised to the 44th power, which equals $168,495. Let's divide your income the first year in retirement by your income the last year you worked. $139,238 divided by $168,495 equals 82.6%. So your retirement income in year 46 starts out at about 83% of what you earned in year 45. Not bad. But how much is that going to buy you? What's the buying power of $139,238 46 years from now if prices are going up 3% each year? We need to discount for 46 years by 1 plus the inflation rate of 3% to get that buying power in today's dollars. 139,238 divided by 1.03 to the 46th power equals $35,747. So the purchasing power of your retirement income in today's dollars is $35,747, which is somewhat less than the purchasing power of the $40,000 you earned the first year of working. This example makes a number of simplifying assumptions and ignores aspects of retirement planning that you might want to consider. What are some of the simplifications? What's ignored? And how could the example incorporate more complexity?